Hello everyone, welcome back. So, the today's topic of discussion is your correlation coefficients and partial correlation coefficient for the three variable model. So, in the three variable model, so we already have the idea about correlation coefficient. We know that it is being denoted by small r, right? So, in the in the case of three variable model, we can compute three correlation coefficients. Okay, so and they are being denoted by these three notations. R12, it is the correlation between your y variable and your x2 variable. R13 is the correlation between your y variable and x3 variable. R23 is the correlation between your x2 and your x3 variable. Okay, so 1 is basically for y variable, 2 is for x2 variable, and 3 is for x3 variable. This is x2. Okay, so these number represents these variables, right? So these R12, R13, R23, they are called Gauss or simple correlation coefficients. So we'll see if there are other forms of correlation coefficients in the upcoming slides. So this is the basic overview. Okay, let's move ahead. So R12 is talking about the correlation between y and x2 variable. Okay, so that is the notation of R12, right? But does R12 measure the true degree of association between y and x2 when a third variable x3 may be associated with both of them? So in the case of three variable regression model, we have an extra x3 variable that is present. Okay, so when I try to compute R12, so is it measuring the true degree of association between y and x2? Like, am I sure about this thing? Because there might be the influence of an extra variable on these two variables, right? So the answer to this is that R12 is not likely to reflect the true degree of association between y and x2 in the presence of x3, because variables might affect each other, and that is why it will not be able to capture, or R12 will not be able to capture the true association between y and x2. So therefore, we need a correlation coefficient that is independent of the influence. Okay, independent of the influence of, if any, of x3 on x2 and y. So I hope this makes sense. Okay, so we need a correlation coefficient that is independent of the influence of x3 on x2 and y, right? Such coefficients are called your partial correlation coefficients. Okay, partial correlation coefficients. What is a partial correlation coefficient? It is basically calculating the effect of, or the correlation between two variables uh, without or not allowing the third variable to influence that correlation. Okay, that is called your partial correlation coefficient. Okay, so this is the way to denote a partial correlation coefficient. So this R12.3 means that it is the partial correlation coefficient between y and x2 when you have fixed the x3 variable, or you have held x3 variable constant. Okay, so whatever number is written after the dot is basically the variable that has been fixed. Okay, just like in this case, the x2 variable is fixed, and the partial correlation coefficient between your y and x3 is being calculated. So R12.3 represents your partial correlation coefficient between y and x2 variable when you are holding your x3 variable constant. Similarly, R13.2 represents the partial correlation coefficient between y and x3 holding x2 constant. And on the same lines, we have R23.1, okay, which is the partial correlation coefficient between x2, x3 holding y constant. Okay, I hope the notation is clear, fairly clear. It's very simple, right? So let's move ahead. So this is the formula to calculate the partial correlation coefficient. This is the formula for partial correlation coefficient. Mind the spelling here, please. So R12.3 is equal to R12, or the correlation between coefficient between y and x2 variable, minus R13 R23 upon under root of 1 minus R2 square 13, sorry, 1 minus R13 square into 1 minus R23 square. So this is how you calculate the values. So every formula starts with the correlation coefficient for which the partial correlation coefficient is being calculated. So R12 is here, R12 is also here, R13 is here, R13 is uh, the first term here. Similarly, R23 is here, R23 is here. So this will help you memorize the formula easily. So you can see the formula, and if possible, try to remember it. So this is how you calculate the partial correlation coefficient. Because why this is important? Because in a three variable or multi-variable model, you might be interested in calculating the correlation coefficient between two variables, but other variables might also be affecting. So the simple or the normal way of calculating the correlation coefficient will not be effective in a multiple regression model, and that is why the idea of partial correlation coefficient. Just like we had the uh, concept of partial coefficient of your uh, x2 and x3 variables, right? We had discussed this in the multiple regression model when we had started the videos. So similarly, we have the partial coefficient, correlation coefficient formulas or concept for the multiple regression model, because we want or we are interested in calculating the impacts or the correlations between two variables without the third or the fourth or the fifth variable affecting that correlation. So this is how you calculate it, right? So first order correlation coefficient. So this is the first, these correlation coefficient are your first order correlation coefficient. Okay, just in here we had seen that these were called your simple correlation coefficients. Okay, because they were just the correlation coefficient between two variables without taking into consideration the third variable, right? So when I add an extra variable, okay, just like in this case I have three variable, in this case I have three variables, okay, in the formula. So the degrees, so this is the first degree because the degree depend on the number of secondary subscript, which is this term, this two, this one here, and this three here. So as the terms here increase, the degree also increases. Okay, so this is these formulas are your first degree or first order correlation coefficient. Similarly, if I have to calculate a correlation coefficient which is of this form, where I have uh, two numbers here in the subscript, then that becomes your second order correlation coefficient. Similarly, this is a third order correlation coefficient. Okay, I hope this concept is clear, right? Let's see what else is there. So now, even if R12 is equal to 0, R12.3 will not be 0 unless R13 or R23 or both are 0. So what it's trying to say is that even if mathematically or R12 is equal to 0, like the correlation coefficient between the x2 and the y variable is 0, R12.3 might not be 0. Okay, so when we calculate the partial correlation coefficient between y and x2 variable by holding your third variable constant, that value might not be 0. So how is this coming? This is coming from this formula itself. This formula. So if I put this value 0 here, this value, if suppose this value is 0, this is equal to 0, this term r12.3 might still not be equal to 0, as you can see from the formula, right? So it will be a negative value, but it will not be equal to 0. So even if the correlation coefficient between y and x2 variable is 0, the correlation coefficient between y and x2 variable, when you hold the x3 variable constant, it is not equal to 0, or it might not be equal to 0. It will depend on the values of other coefficient like r13, r23, or both the values. Okay. So similarly, if r12 is equal to 0, r13 and r23 are non-zero and are of the same sign. R23, r12.3 will be negative. So if both of these values, so if r12 is equal to 0, r12 is equal to 0, and these are of the same sign, r13 and r23. So if they are of the same sign, it means that this entire term will remain negative. So it is that's what it is trying to say. If this is equal to 0 and 1 3 and 2 3 are of the same sign, then r1 2 3 will be negative, right? So this is basically the use of the formula, and you can always get around these things by looking at the formula, and that is why I think the formula memorization will be important for you. So in the two variable case, r square lies between 0 and 1. So we know that the value of r square lies between 0 and 1. So this is a formula that will follow this rule. So r12 square plus r13 square plus r23 square minus r12 r23 r13 r23 will be between 0 and 1. So in the case of three variable regression model, instead of this being followed, this will be followed. So this is a property that can be asked in the question form. So you have to remember this also, right? So if r13 and r23 is equal to 0, it does not implies that r12 is equal to 0. So just think about this. Just think about this, okay? And it will make sense to you. So this is something I'm leaving for you to think, and just give it a thought. It's a very simple thing. You can also use the formula if you want. So this is all for this video, I think, and I hope you understood what partial correlation coefficient are and why they are important. So this is all. I'll see you in the next video very soon. So till then, take care. Bye bye.